derive the electric potential due to an electric dipole. What is in the electric dipole? Electric dipole is nothing but whenever there are two charges placed in a medium. Suppose two charges is plus q and minus q, and they are separated by distance twice L. Now they form a electric dipole. This concept is same as that of a magnetic dipole. What is meant by magnetic dipole? Whenever there is a magnet with N pole and S pole with polarity or pole strength plus m, small m, and minus m, and the distance between them is twice L, 2 into L. Then what is our magnetic dipole moment? We was writing that magnetic dipole moment in 11th standard. This is the concept from 11th standard. Magnetic dipole moment is the product of pole strength and the distance twice L. Same logic or same concept will be there. Electric dipole is denoted by P, and it's the product of charge and the distance between them is twice L. Therefore, P is the electric dipole moment. P is equal to Q into twice L. Okay. Therefore, di means 2 and pole means polarity. Therefore, consider two charges. Now observe the diagram. Two charges plus Q and minus Q are placed at point A and B, separated by a distance twice L. Let O be the center of the two charges, and therefore automatically the distance AO and BO is small l. Okay, small l distance is there. Now consider a point C anywhere in the medium at which we required electric potential due to this electric dipole. Due to this plus q and minus q charge simultaneously, what is the value of electric potential at point C? Therefore, we consider the distance of a point C from center of a electric dipole is r. It makes an angle theta with the axis of a dipole. Axis means what? The line which passes through the two poles and along the two poles. This line, this red line, is a axis of a dipole. Similarly, what is the equator of dipole? A line which is perpendicular to the axis of a dipole. That line is known as a equator of dipole. Okay. Therefore, what we will do now? Consider point C, which makes an angle theta with the axis of a dipole, and r is its distance. Then we consider r1 is the distance of point C from first charge, and r2 is the distance of point C from second charge. Therefore, we write the potential due to first charge V1 is equal to, see the equation number 2, plus q upon 4 pi epsilon 0 r1. Similarly, V2 is equal to minus q divided by 4 pi epsilon 0 r2, equation number 3. This one is for V2. And what is the effective potential at point C? Therefore, we add these two relations. Therefore, add equation number 2 and 3. Now, when we add equation number 2 and 3, q upon 4 pi epsilon 0 is a common term, and in bracket we get 1 upon r1 minus 1 upon r2. Now, remaining part is related with the solution of 1 upon r1 minus 1 upon r2. How we will calculate? Why we required 1 upon r1 minus 1 upon r2 to solve? Because we will convert our answer in terms of r and theta, and therefore we are following or doing following steps. Now what our first step, I will apply a cosine rule for this triangle, first triangle, then apply the cosine rule for this second triangle, which gives us the value for r1 and r2. Okay, observe the steps carefully. Therefore, what is by applying, what is that step? That step is here. Apply cosine rule for triangle COA and triangle COB. We get, what we get? r1 square is equal to r square plus l square minus twice rl cos theta. Similarly, r2 square is equal to r square, that steps are here, r square plus l square plus twice rl cos theta. Therefore, what is my next step? I will take this r square common. Okay. Therefore, when we take r square common from this equation, from r1 square and r2 square, take r square common, we get, what is that equation? 1 plus l square upon r square minus twice rl cos theta. Similarly, what we'll get? r2 square is equal to r square 1 plus l square upon r square plus twice l upon r cos theta. As l is very small as compared to r, what is l? L is nothing but this distance. And what is r? This one. Therefore, l is small as compared to r. And if the term l square will be there, it will be much smaller than r or r square. Therefore, we neglect the l square upon r square terms. Okay. Therefore, see the next step. We neglect the l square upon r square terms from above equations. Therefore, what we get? We get r square is equal to, observe here carefully, r square is equal to, r1 square is equal to r square 1 minus twice l upon r cos theta, and r2 square is equal to r square 1 plus twice l upon r cos theta. These two equations are there. Now, what is my next step? I required 1 upon r1 minus 1 upon r2. Therefore, first of all, I have to calculate r1. Therefore, take a square root on both the sides of these two equations. Therefore, r1 is equal to r 1 minus twice l cos theta raised to 1/2. Raised to 1/2 means square root. Similarly, write for the r2 also. Okay, now what is my next step? As I want 1 upon r1. In these steps we have calculated r1 and r2. Now what is my next step? I have to calculate 1 upon r1 and 1 upon r2. Therefore, take a inverse or 1 upon of first equation, second equation. Therefore, 1 upon r is equal to 1 minus twice l cos theta upon r raised to minus 1/2. Here also raised to minus 1/2. Why there is a minus sign? Because we are taking, what is the 1 upon x? Can I write x raised to minus 1? Similarly, 1 upon square root of x, which becomes 1 upon x raised to 1/2, which is nothing but x raised to minus 1/2. And therefore, we are writing here minus 1/2. Okay, got it? Now, what is my next step? First, we use the binomial equation. Binomial equation of 1 plus x raised to n is equal to 1 plus nx plus dash dash dash. Neglect the higher order terms. Again the concept is same, as L is smaller than r and L square is becomes much smaller than r square. Therefore neglect the higher order terms of L square upon r square and just keep the first order term. And therefore what is will keep the terms of L upon r only, and we get the relation. Therefore by using binomial equation, our above these two equation becomes 1 upon r1 is equal to 1 upon r1 plus, why there is a plus sign? Because x raised 1 plus n into x, n is minus 1 half, and that 2 get cancelled, and we get the relation 1 upon r1 is equal to 1 upon r 1 plus L cos theta upon r. Similarly 1 upon r2 is equal to 1 upon r 1 minus L cos theta upon r. Now put these values into our equation number 4 in this equation and calculate the answer. If we will solve the equation, common term is 1 upon r outside the bracket. Common term is a 1 upon r outside the bracket, and 1 plus L cos theta upon r minus 1 minus minus becomes plus L cos theta upon r. 1 get cancelled and the remaining terms are here is the answer. Remaining term is q upon twice L cos theta upon 4 pi epsilon 0 r into r, it becomes p cos theta upon r square. Therefore p cos theta upon r square is our answer. Why it becomes p? By using equation number 1. It's the product of q into twice L becomes p, and r into r becomes r square. This is the required expression for electric potential due to electric potential at different positions. Means if theta is 0, theta is 0 means what? Along the axis of a dipole. What is theta? Observe your diagram. In our diagram, theta is the angle between point C and the axis of a magnet. If this theta is 0, means that point C may be here or may be here. If that point C is here, that angle will be a 180 degree. And if that point C is along this line, then that theta will be 0. And thus, if the theta angle between point C and the axis is 0 or 180 degree, then that point will be an axial point and the electric potential will be maximum, and its value is 1 upon 4 pi epsilon 0 p upon r square. Maximum value you will get along the axis. Similarly, we will consider another case. What is that next case? If theta is 90 degree, means point C is situated along the equator of a dipole. Then what is the cos 90? As cos 90 is 0, automatically our answer will be 0, and therefore the electric potential along the equator of a dipole is a 0, and it's a minimum value. Where is the equator? Observe the diagram, then you will come to know that if this point C is perpendicular to the axis, means this angle is now theta is equal to 90 degree. Then what happen? At that point, the electric potential at point C due to the plus q charge and minus q charge becomes 0. From diagram or from the symmetry of diagram, can you explain this answer why it's 0? It's 0 because along the equatorial point r1 and r2 becomes equal, and what is our relation? 1 upon r1 minus 1 upon r2, automatically 1 upon r1 minus 1 upon r2 becomes 0 because r1 and r2 are equidistant along the equator, and therefore we will get the answer 0 along the equator, and it's our minimum answer. This is the expression for electric potential due to a electric dipole. Now instead of two charges, lot of charges are there. Therefore, what is the electric potential due to a system of charges? Due to system of charges means more charges. If these charges are placed q1, q2, q3, q4 at distances r1, r2, r3, r4 respectively from the any point, and at point P I require the electric potential, then what we will do? We will write the electric potential of each charge as a V1, V2, etc. dash 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 for V3, V4, and we add the answers. And therefore, what we'll get then? We'll get the common term as a 1 upon 4 pi epsilon 0 and all the summation of charges divided by its distance, and this is the required expression for the 1 upon 4 pi epsilon 0 summation of qi ri is the expression for electric potential due to a system of charges.